Alright, time for another DraftPhysics.com, debatephysics.com video presentation. Bit of a sciatic nerve problem, but I will try to get through it. Yeah, anyway. Alright, so there's a video by NP Life Apologist. Don't know who, it's probably a Farley or something, using the fake voice thing, blah, blah, blah. Anyway, it's just another one of these 3-minute videos that really doesn't do any physics, but just makes some sort of assertion that physics is, I don't know, something not worthy of discussion, I guess. What other point are they making? But anyway, let's just play some of it and see how it goes.
Potential energy.
Ooh, too loud. Potential energy. So, there is no such thing, right? Okay, so I have... Oh, Jesus, this should work. Come on. Oh, there. Yeah. This computer's a little buggy, too. Way buggy. Yeah, way buggy. I guess I gotta fix this. I don't know what the fuck's wrong. Yeah, it's bad. Alright, well, that's life, I guess. We'll see how it goes. I mean, it's just not working right. Unfortunately. So, moving on. Let's see if we can mush through its lack of functionality.
Energy is not stating that the item, or weight, has that much energy.
Alright, so this whole word potential energy doesn't really mean anything, right? I mean, it's just energy, and the point is whether you can convert it, whether you can transfer it. So if two things are falling, they both have potential energy relative to the ground, but if they're falling at the same speed, they won't have any energy relative to each other. They can't transfer any energy because they don't have any differential. So there's just differentials in energy, you could argue. Things are of different temperatures. Now I could also argue that temperature and motion are the same thing. And then you could counter-argue by explaining how, that's not true. So let me illustrate. And see, these illustrations are part of what physics should be, in my opinion. So you could argue, oh no, it's totally unnecessary to illustrate anything, and that would be interesting for you to make that argument, that illustrations are of no value. But it's just because we're entirely different people. We understand what an argument is and how to argue in completely different ways. You think this isn't part of the process of even a lawyer explaining something, would be to use diagrams or illustrations. Alright, so my basic argument would be is that, this idea of what heat is just little stuff, okay, moving. So that could be understood, that it's just little stuff that has more motion, and therefore it ends up being, you could say further separated because it is more active, and each little piece has more motion, and the more motion means that every time they hit each other they go a little faster, and the faster they go, the more pressure they put on the outside of a vessel. And I would argue that yes, that's all true, and that motion is really just that heat in one direction. So if you can give things motion in the same direction, then you'll physically have something big that's collected heat in one direction, effectively. So it's hot in one direction, effectively. And that you could reduce it back to heat in all directions by creating friction or some other thing to take the motion away. So the momentum is just heat in one direction, and that you could put it back as heat in all directions, by putting it back into the little microscopic elements. But that's the basic concept, and that everything is just mass with a velocity, and that defines its energy or its heat or its weight. All of these things are the same thing. Alright, so you didn't need much of an illustration, but it helps. So the idea of potential doesn't really mean anything. Potential just means that there's some place where there's something happening, and you can stick your finger in it, so to speak, like a stream. So if there's a stream of water and you're moving as fast as the water, you can't exchange with the water. But if you're not moving as fast as the water, if the water is moving some other different direction, or if it's moving at a different speed, then you can stick your finger in it and you can collect that difference. It will share its state with you. So if it's hotter than you get hot. If it's cooler than you, then you give away some of your heat. And the heat can just mean you go in a different direction, which might be the cold direction from its standard, but I just mean it just really has to do with movement. Something really is moving and something isn't. And the fact is that you can always exchange those differences between things that are moving more and things are moving less in a particular direction. So, yeah, but that's all. There's no potential energy. There's just energy in a place where you can tap it, where you can put your boat in it and go somewhere. And there's other places where, no, there isn't any energy. It's going the same speed as you are, the pond water, and it's doing the same thing you are. It's not doing something different. So you can't share your differences and collect the difference. That's simple, really. All right. Come on. Thank you, computer. Please work more often. Anyway, better. So he's showing my pendulum, which is very nice, and using this as an illustration. Okay. But yeah, he's really not explaining anything, so I'll do that part.
It's stating that as far as the fulcrum is concerned, the weights are equal, regardless of how much energy each one actually has.
So that doesn't even make any sense. Regardless of how much energy each one has. The whole point is to define where the energy is, to do a force diagram and explain where the forces are and how the forces are acting. That's physics, okay? And so you're pretending that you can just say these words and negate the fact that there's a different amount of kinetic energy on these two sides of the fulcrum. And there really can't be, because their behavior is the same. If the behavior is the same, there really can't be a different amount of energy, because the energy is in one side and then it switches to the other side. It's always gravity that's providing the energy, and gravity is giving the same energy in both cases, because the motion is exactly the same. So I guess that might be worth illustrating.
Physics doesn't know what's on the arm of the lever, so it's referred to as potential.
So it's just, you referring to it as potential is just wrong, because we know exactly what it's created by. So when it's tilted up, there's a little bit of extra lever down here that ends up on this side of the fulcrum. Now this side has more total mass, weight, let's just say, because it really just isn't about the mass, it's about the weight. The weights are even. The things hanging on have a weight that's equal. They don't have an equal mass, they have an equal weight. But the lever itself is just a mass, because there's the same amount of it on both sides. And when it's tilting up, then there's more mass on this side. When it's tilted this way, there's more mass on that side. And that's why it keeps moving. It's a small amount of energy in the system, but you can't deny the fact that there's the same energy on both sides, and that means, by your theory, there's more kinetic energy on one side than the other side, which really can't be.
Then again, I could be wrong. I am no expert.
Then why are you doing this? Why are you interfering then? Why are you even saying anything if you're not an expert, or your opinion isn't qualified by some sort of knowledge? Why are you opining? You're basically just saying you're not qualified, your opinion isn't qualified, and therefore blah blah blah. What's the point of that? And you're not going to do any detail. You're not going to give us any of these details. So of what value could your opinion be in that context? It could just be noise. You could be saying something completely wrong and very unproductive. It's like you trying to drive a car when you don't know how to drive. You know, there's two people fighting over driving the car, and then you want to interfere and say, oh, stop fighting, I'll drive. But I don't know how to drive. I mean, what's the point in that? Not very logical. The pain. Anyway, so this is what I did on the lever. So we have a 4 mass here and a 1 mass 4 distances out, and that ends up being equal. And the trick to it all can be understood if you make the lever really fat. Then you can sort of understand what's happening. Is when the lever, when this side tilts up, you can understand that this whole portion of the mass ends up on this side of the lever. And when it tilts the other way, you end up with this whole side of mass that ends up on this side of the lever. So it's that little mass shift that's actually causing the lever to move up and down, the pendulum or oscillator, whatever you want to call it. So that's the energy, is that it swings down, it gains momentum, the momentum has to be eaten up, okay? So its maximum speed is here at the neutral point, okay? That's the maximum velocity. And the simple argument is if I put a stop here, so when it's swinging up, it hits the stop, and these things could fly off. They would fly off at a velocity, okay? And that velocity would be 1/4 of the velocity of the thing out here. So this would have 1 velocity and 4 mass. And if I did the opposite and stopped it going the other way, okay, put a stop here and let this fly off, it would leave with a 4 velocity and 1 mass. Alright, those things, those momentums are even. But as kinetic energies, this is 4x the kinetic energy. So that's where the problem arises. Okay, that you can't really say that it has 4 times the energy when this little bit of mass is over here, and then it only has 1/4 of the energy when the mass is switched to the other side. So when the gravitational mass changes, flips, you're saying that somehow it has more energy. That would mean that this, when it hits the stop going one way, it would have to incur more energy, hit it harder. And I can't prove that it doesn't, but it doesn't. Okay, so that's just a nonsense argument. The absolute fact is the lever's motion is even going both ways. The amount of lever moving is the same on both sides, and everything changed is how much this mass is moving. And that's the only difference when the energy is on one side or when the energy is on the other side, is how much of this mass is moving. And again, the momentum is equal, but the kinetic energy is not, and therefore it doesn't make any sense. You can't really have more energy on one side than the other side and call it an oscillator. That's what you're supposed to counter argue with some explanation about where the energy is, how you can have uneven. To have equal kinetic energy, you need to have unequal momentum. That's the part you'd have to explain, is how did the gravity create unequal momentum? Alright, continuing. Such.
Maybe you've stumbled upon a Nobel Prize.
So again, that's really not what the subject is about. But I will just assert that obviously, if I'm right, it's a profound alteration to the physics model. I mean, a gigantic alteration. Just like if I'm right about photons and the fact that the surfaces are causing the phenomenon, it's a complete reversal, a complete change of the whole picture of what a photon is. So I mean, let's not play a game that it wouldn't be Nobel Prize worthy in the sense that it would be more dramatic. There wouldn't be a Nobel Prize that has been issued for some more dramatic discovery. Okay, it's about as dramatic a discovery as you could possibly describe in terms of how radical it changes the physics. So why, why pretend if I'm right it wouldn't be worthy of a Nobel Prize? You're just almost saying you're too big an imbecile to figure out that if I completely change the standard model, I wouldn't be entitled to a Nobel Prize? I mean, come on, that's a ridiculous argument to make.
Or not. Just try to have fun with this topic.
Oh, what's the point of that? And frankly, it's not me who took the fun out of it. All right, it's the naysayers who are jihading, okay, against anyone be a dissenter from their club, their Catholicism. So they're the ones with the radical rhetoric, the excessive rhetoric, the unfun rhetoric, yourself included.
And I guess life in general.
Yeah, well, fuck that. Okay, you don't want to take it seriously, that's your problem. I think it's serious business, so I hope you get what you deserve. That is, I hope you get treated as badly as you treat other living creatures on Earth. I hope you get that same nihilistic, neglectful, ignorant dismissal. I hope there's some point in your life where somebody dismisses the integrity of your humanity, okay, in some grotesque way, because that's exactly what you deserve.
Not many people want to see angry rants all of...
Apparently you do. So what's the point? What's the point? The fact is arguments are a fact of life. And if nobody's willing to have them, then nothing gets tested, nothing good will happen. Just a bunch of wacky and silly stuff happens if no one stands up and argues and says, don't do that, it's dumb. Somebody has to do that, jackass. And if you don't have the courage to be one of those people, then just say you're too much of a wormy, squirmy, selfish jackass to be part of the process. Okay, just admit that you're a useless pile of shit that can't fix or help or do anything. But no point in mocking people who do try. Fuckhead.
The time, even if you are right, as two or more things...
Yeah, even if you're right is even stupider thing to say. I mean, if you had some reason to be confident I was wrong, that would be something. But to say, even though I am right, I should leave it broken. Because broken's better. Too fucking silly. So he's got a clip now of this silly bullet into bullet thing, which proves my theory essentially. Okay, it's a kinetic, it's a momentum experiment at its base. So how the hell is this anything? How does this explain anything? How does this in any way counter anything I've said? No, that's right, it doesn't.
Collide, the potential energy is then made true.
So again, the potential is just in their directional difference. If they were going the same way, they couldn't exchange any energy. Nothing could happen. They couldn't convert. They couldn't make an exchange. They couldn't make anything happen. But the fact that they have exact opposite vectors, that is, their heat is going in exact opposite directions, therefore they have a lot of heat. A lot of heat difference. The difference is all that matters, is your temperature difference. They sort of had a very high temperature difference because they both had very high velocities in exactly opposite directions. Not hard to figure out what's going to happen at all.
And the leftover energy is either transferred into...
There's no leftover. They don't go anywhere, as it's quite obvious. The bullets aren't going anywhere. The little pieces are going somewhere. And so all the momentum has been converted into smaller pieces going places. There's no longer two bullets going anywhere. There's just fragments going somewhere. But yes, you add up all the fragments, you got the same momentum. You don't have the same kinetic energy. You have the same momentum.
heat, sound, or dissipates into equilibrium.
Right. See, all those heat and sound are the same thing. Sound is just a vibration in the atmosphere. How is it distinct? It's just heat in the atmosphere. The atmosphere gets hot when you have sound in it. If you put a lot of sound in the air will actually get hot. Sound is motion.
Through the path of least resistance to the ground.
So again, this path of least resistance, if there's any resistance, then that's friction. That friction, it converts to heat. So again, it all comes back down to heat. It all turns back into little tiny things moving. Electrons and protons ultimately are the smallest things you can move. So you can give your velocity to electrons and protons, like in a battery, or you can take it from an environment, put it into an object, and use like a rocket engine to send the heat in one direction.
You smack two heavy metal.
So again, this is an experiment I've described in my own videos. So clearly this isn't any kind of counter argument at all.
Balls together, the energy of their collision will be focused at such a small point enough heat can be produced to live.
So it's not the energy of the collision, it's the fact that he's not letting them bounce off of each other. If he lets them bounce off of each other, they don't make any heat. The fact that he pushed them in and held them, forced them to stay connected, he added more force so they couldn't bounce. That's why it got hot, is because they kept bouncing. It's just you didn't see it, little tiny bounces. So this you can see with the anvil experiment. So when they do the anvil experiment, yeah, it bounces and then it bounces and then it bounces and then it bounces. So let's say 25 of the bounces are visible. The other 175 bounces are little tiny little bounces. Almost imperceptible, but you can hear them. They're so small you can hear them because they're traveling such a tiny amount of distance. So that's what's happening there. Is he's taking the energy and forcing it back and forth between the two balls at a very high speed, and that's what's burning the paper. Is he's sending a lot of wattage back and forth through the paper. Do you have a counter theory?
Literally burn a hole through paper.
Look at that spring stretch.
So I played this video in one of my videos. It's really quite useless. It doesn't do anything, doesn't say anything different than what I've been saying. It's momentum. There's nothing about kinetic energy in here at all. It's perfectly consistent with the theory of momentum. It's a lever. Levers are conservation. They conserve momentum. In all of the standard lever examples, it's conservation of momentum.
The setup, it seems pretty simple. And actually, scientists have a special name for this simple setup. They call it a simple machine. It's taking 1,000...
So again, nothing meaningful in those silly words, right? No, not really.
...gram weight and making it almost feel like...
Right, it feels like it, but you have to do the feel like for 4 times the amount of time. So something that you did really quick, you've converted in something you're doing very slowly. So yes, you have to spend more time lifting when it weighs 10 pounds. You lift it more time to equal the 100 pounds. Where if it was 100 pounds, you need to lift it all at once. And so it's harder because you're lifting all of the weight all at once. Where in the other case, you've broken the weight down into a much lighter weight over a much larger amount of lifting distance. Not that complicated, really. I mean, I could illustrate that, but again, that mechanics is Newtonian and momentum based. It doesn't have anything to do with kinetic energy.
It almost feel like 350 grams. See, our whole setup of our lever, our simple machine, we have our pivot point or fulcrum.
Right, and the point is that you had to do the more work of traveling more distance to affect the tiny amount of lifting. Okay, so there's 2 ways to do the lifting: spread it over more time, or have to do it all at once. And obviously, if you have to lift it all at once, you need to be able to sustain the pressure, the higher pressure of doing it faster. Doing things faster usually involves more pressure, and we're not able to assert the extra pressure without breaking parts of ourselves or hurting ourselves. So we reduce the pressure using these tools. Again, not complicated and not really the subject of kinetic energy.
Weight right here, and I pull up on this end. It really makes me think of something.
So, you know. And so he says, and now for something more important. What could that be? I wonder.
This starts with a once upon a time story. I have graduated from the university.
Alright, so I don't know if there's any point in playing this, actually. So he just plays some nutter talking about some UFO thing. You know, so it's just one of these standard people. It says, I talked to the UFO and it gave me the special crystal, but I put the crystal in my pocket and it fell out of my pocket, so I can't show it to you because I lost it on my way home. You know, it's one of those typical stories about some magical piece of cloth some grammar school student gave him, who no doubt he can't remember her name. You know. So, and he ends it with, like, this somehow, I'm supposed to take some kind of, this is supposed to be meaningful, because apparently he's saying, when I point out that Leibniz was wrong, okay, that 4 pounds dropped 1 foot is not the same energy as 1 pound dropped 4 feet, I'm being some sort of crackpot to point that out. And when I point out dropping round things, denting clay with round surfaces, is not going to produce linear results indicating total energy. It won't work as an energy detector. That again is being a UFO
And I jammed that in.
liar. Now these people are liars, right? So it's just, you know, so his accusation is that I'm contrived a lie story. It's not true that Leibniz says 4 pounds dropped 1 foot equals 1 pound dropped 4 feet. Even though it's in a written record and it's historical fact, I'm lying. Okay. You see just how this is the best they can do. So he only posts a 3 minute and 28 second video, and the whole second half of it is this misrepresentation or this accusation that somehow all the arguments I've made are rubbish and garbage. They're lies and made up fables. When no, they're not. They're a citation to actual experimental truth. You know, when I point out that the Eddington experiment hasn't been repeated from Earth successfully, it just is the truth. The fact that it's never been tried from space with 400 times resolution, those are facts. Those aren't lies. Those aren't fables. Those aren't distortions of the reality. I mean, you people are so dishonest. So this is you being showing you have something called integrity to make this kind of argument? I would argue that clearly it's showing you have no integrity.
UFOs. This is actually 17 years after, or 18 years after Roswell.
Does he look and sound like a kook to you? Yes. Yeah. Yeah, no point. I mean, yeah, it's a silly little story. Some little kid show. I mean, it's silly for so many reasons. You know. What's the point? I mean, what's your point? You're the one relying on something that's never been demonstrated to be true. So, you like the kook, you're showing up with the magic theory that says it takes 25 times the fuel to go 5 times as fast. So you're showing up and saying that, well, look, I went in this car ride with this guy who had this magical device that, you know, the fuel went through a tube, and you could see how much fuel went through the tube by volume. Yeah, per minute. And you know, with this magical device, you know, he ran a car and he went 5 miles an hour, and you know, there was so much fuel going through the tube, and then when he went 10 miles an hour, there was twice as much, you know. Wait a minute, no, there was 4 times as much fuel going through the tube when he went 10 miles an hour. And then when he went 15 miles an hour, there were 9 times as much, you know, fuel going through the tube. Come on. I'm the nutter? Just really pathetic. Shamefully short of a counter argument, that's for sure. Alright, so we had some other little nothing video. The Michael Falwell guy has some Star Wars, some 15-second video where I guess the Emperor is saying something about the Force. I don't know. I didn't play it. It's just like, what the fuck? This is how you explain why you believe. Okay, you believe they are right. I don't think you understand any of the elemental physics, and what you really are, the most disgusting part of your counter argument is your unwillingness to acknowledge all these experiments should have already been done. I mean, the fact that you won't even acknowledge that you wish and you think it would be so much better if physics would have spent 1/millionth of the money they spent on accelerators and all that stuff, 1/billionth of the amount of money they spent on accelerators, and spent it just itemizing these basic elemental facts. You know, just doing the lever experiments, crashing some cars into each other, you know, just basic dynamical experiments just to establish the truth. And the fact that you can't even utter those words, that you wish physics, the science of physics, had actually done some experiments, instead of just saying what the truth is, they actually proved it with experimental facts and data. You know, the fact that you can't even say those words makes you so disingenuous. So, oh fuck, you gotta be just liars and thieves, right? You can't admit that the science has fallen short of what it should have done. It's come to court with bullshit evidence. I mean, a drawn picture of a gun, a drawn picture of a fingerprint. You know, there's no real evidence. You people are just so, you suck. You're just such pieces of suck. Alright, so this is a second video by the asshole. And so, let's play that.
Draw up a proper experiment example.
So, yeah, we've done that each time. And the fact is, because none of these experiments have been done, in every case, we have confronted the fact that the experiment has variables we didn't anticipate. It's just a fact. I didn't know like I said, catapult argument is right there in my face. I mean, yeah, I thought it's a way of getting out of this crap about gravity. Okay, let's get gravity out of the equation and shoot things sideways with a catapult, and it seemed to make perfect sense. But then I didn't realize, no, the catapult can move at different speeds depending on what it's launching, and if it moves at a different speed, it's absorbing a different percentage of the energy. So I mean, there's all kinds of variables, but in every case, some of these experiments have been drawn out. Some of them are simple. I mean, Ian Gosling just dropping weights on Play-Doh wasn't very complicated. So what is your argument? I'm supposed to, you know, I didn't think up Brozo's experiment, putting, you know, sawing a billiard ball, sawing the sides off one. I didn't think up that. That's his idea. Not a bad idea, frankly. So there's a lot of good things that have been figured out how to do it, to try to get to the core, to try to get to the real thing. Now, not so good an idea in his experiments are, you know, disk drives as wheels. Really good for lack of friction, but really bad for the fact that you end up with a lot of your velocity in angular momentum rather than linear momentum. So, you know, all of these things have to be understood. So I don't think this is the issue, that somebody hasn't drawn up the experiment. It's just that none of us have seen the experiments done, and they're all being done for the first time, pretty much, and none of us are experts. You know, so you have to do the experiment to learn your lessons about, you know, what really does work and what doesn't work. Quick releases, for example. I didn't think they were that important when we started this. I didn't. You know, I thought, oh yeah, it's great, but I'm just pulling a rubber band back. How slow can my fingers be? And I found out, oh, they could be pretty bad. So you do the experiment and you learn. So this isn't the problem. The problem is that you all think the experiment's supposed to be really simple, in spite of the fact that we've learned it's never that simple.
What you actually would like to see. Is this example good enough?
I think in some cases the examples we have are pretty good. Now, a coupled oscillator is a pretty simple concept. So once you've created a coupled oscillator between two pendulums with different masses on them, it's obvious whether it's working or not. If it's working, one object stops moving and the other one object's moving. And then if this one stops, then this one's doing all the moving. So a coupled oscillator is a pretty good experiment. It's I've drawn one. I've illustrated it, and then I did it. Now, what I didn't have was great measuring tools to see exactly how much motion is in the two objects. They didn't move perfectly linearly, so there's a few little defects, but I'm arguing that certainly if somebody does do the experiment with timing gates and all that kind of crap, that they're going to find out that, yeah, it's the same momentum on both sides. Not the same kinetic energy, the same momentum.
Be more detailed with your request.
So again, more bullshit. I'm not requesting anything in the first place. It's not, the challenge I placed that I was going to pay somebody to do was come up with a kinetic energy experiment, okay, that proves the case. And I'll pay you. I didn't have one specific experiment say, do this one experiment. That proves everything. That's really not the truth. But the truth is that I think if anybody else in this conversation is honest, then they'll admit that, yeah, all these experiments are more complicated than what you at first glance. Even dropping things in gravity is a little more complicated, but you have to think about there's two elements. There's the amount of energy being produced by the falling, and then there's just the weight of the object itself. It still has weight in gravity. So when it has an impulse energy of hitting a surface, it's not hitting it with just the energy it collected, it's also hitting it with its weight, its gravitational weight. I mean, these are things you have to think about to discover, and you're mocking that again. That's your contribution, is to mock the complexity. Joule spent decades of his life trying to engineer machines to do exactly what we're trying to do, which is detect energy. And in frank truth, only half of his device was coherent, in the sense that the idea of creating a insulated tub of water and then causing agitation in the water is sound. Now, the fact that you have to do it through pulleys and other devices that are going to suck up some of your energy, that's not too good. And the other problem being that he's calculating the energy by dropping a mass instead of having a horse do it or something, instead of having the energy provided by some other known amount of force, which is, then you're really getting into the pretense of thinking that distance is always the same energy no matter what speed you travel it, and it's not the same energy.
How can you possibly demand people be accurate with experiments when you...
So again, shouldn't everybody demand that the experiments be representing the truth and not a misrepresentation? So somebody could do the clay, dropping round things in the clay, and do it very clinically and very carefully. But the problem is it's theoretically broken. It can't work theoretically. It doesn't have any theoretical hope. So that's another complication. Some experiments are theoretically broken, and some are difficult mechanically.
You don't even bother measuring. Lines on old printer paper? Are you...
I didn't publish any of those results as a proof. None of my videos were titled proof of. Alright? So yeah, that's the best I could put together just to show a demonstration of my challenge that, I don't think they have it right. And so here's an example of the experiment done crudely, okay, and the results don't look like theirs. That's all it was there for. It was just to show, I don't think they're doing it quite right. And I was showing how I'm trying to do it right by having a thin lever and having heavy masses and having long pendulums, not short pendulums. So I showed the advantages of the way I was doing the experiment, and I pointed out clearly that this is just a crude version, that I'd like to do it better than this. I'd like to have it done better than this. But don't lie and claim that I'm the one titling videos proof of, because that's not what I'm doing.
Serious? Please just use a computer simulation for...
Oh, I mean, that's just so that's so obnoxiously irrelevant. A computer simulation based on what? On their lies, on their falsehoods, on their fakery? F equals MA? Fuck you. That's just nonsense. You can make a simulation prove anything. Why the fuck would that be at all interesting? You're trying to find out what the simulation should be, what the math in the simulation should be. That's what we're trying to find out. You can't use a simulation to prove the right simulation. It's just the silliest thing you said so far.
your experiments, if you're not going to be bothered doing them in real life.
Oh, so again, I'm not going to be bothered. The accusation is that your physics has had 350 years, if you go all the way back to Galileo, 500 years, to establish these proofs of this, of what happens. Now, Galileo proposed different laws of motion. Descartes proposed laws of motion. Leibniz proposed laws of motion. Newton proposed laws of motion. And all of them are a little bit imperfect. And ever since then, science hasn't proposed any laws of motion. Nobody, no physicist has sat there in a lab and taken some pendulums and banged them into each other and, carefully tested, like the Copenhagen experiment. Nobody's carefully tested to see if they can measure the kinetic energy and the momentum. These experiments haven't been done by physics. And here you are yelling at me about my unwillingness to do experiments? I mean, it's a joke. You're the one with the claims and no evidence. You claim it takes 25 times the fuel to go 5 times as fast. Your claim is that if I make something go 5 times as fast, it does 25 times the damage. Do you have any evidence indicating that's actually true? No. Zero. Nothing you can show me. Nothing.
Stop asking others to do something, and then tell them they did it wrong.
Well, that's again just a lie. I didn't ask Dispar, I didn't ask Brozo, didn't ask any of these people to do a goddamn thing. And I certainly didn't even say, frankly, that you have to do it my way or you have to do it this professional way. All I said is don't call it a proof when it's really not up to the standards that it should be to be a proof. If you're going to claim something bold, then you really should have solid evidence, not evidence without quick releases and without, where your cart, you lift your hand off the cart and the cart's moving down the track. I mean, that kind of crap shouldn't happen in your proof experiments. Proof experiments should be really, really duplicatable and reliable.
You will never be satisfied this way.
So this is just more nonsense. Satisfied by what? So again, he puts physics girl up here. That was a glaring example of a completely nonsensical argument. Her argument was you showed the bullets crashing into each other and the little pieces flying off. And the bullets don't go anywhere because the little pieces fly off. Well, she says both of these things can happen. That the bullets could keep going and the pieces could fly off. You could do both. That's her theory. Her theory is the bowling ball can knock down all the pins and still be going the same speed, keep all of its momentum. Doesn't have to lose any momentum. I mean, it's so silly and so nonsensical. It's just flatly nonsensical. Physics doesn't work that way. The physical reality doesn't work that way. You can't do work without using something's momentum. Alright, I'm back. The pain and such.
Do something practical, and maybe...
So, whatever. So all this is part of the record, right? So the practical thing I'm doing is proving, besides fixing physics, is I'm proving a huge defect in the human organism. In the sense that we think that, it's only a few people or a small percentage of people who are closed-minded, brick-headed, moronic fanatics. believers without good reason. Religious kooks even, you could argue, that this is just a symptom of being ignorant. But no, it's a symptom of something deeper, because you're not ignorant. But you're too stupid not to realize that you're behaving as if you are ignorant. I mean, not to admit that it's physics' responsibility to do experiments. I mean, not to admit that you really don't have science without that, without those details, without establishing a proof for an assertion. They shouldn't be making assertions about how reality works unless they can demonstrate it with some sort of evidence. To not even understand that, what, you're too stupid to know that? I think you know that, and you're denying it. So it's a deeper corruption. It's just not ignorance that's the enemy. It's belligerent ignorance.
Maybe shut down the debate competition, considering you're demanding only those with over 200,000 subscribers can enter.
I'm demanding that the only useful conversation is one that has more people in it. That a conversation among a bunch of loonies on the internet, and frankly that's all that's watching so far, okay, are marginals. Let's just call them that, okay? What we're looking for is people who have a physics education. People who have watched as many physics lectures as I have. That's what we need in the conversation. Somebody who can say, well, what about when Lewin said? What about the experiment that? We need those people in the conversation. We need people capable of understanding when I say, they're drawing the two slit wrong. They know, oh yeah, they are drawing it wrong because, yeah, that's right. There's two patterns. There's an envelope pattern. I mean, they're completely overlooking the most important features created by the classic double slit. I mean, just fringe pattern isn't the double slit. It's fringe pattern inside an envelope. That's the double slit. That's what you have to have in the conversation. So my whole point is to get more people in the conversation. I don't need to have, there's no point in me having an argument with a non-physicist with less than the number of subscribers I have, or less of an audience than I have. I need a bigger audience, not a smaller one. You don't understand that? We're hunting. I'm offering, what do you think I'm offering the money for? Is to get a qualified opinion, to get a physicist to put their reputation on the line. I'm not going to get that by talking to somebody with 300 subscribers. Moron.
Sure. So obtuse.
So what a useless pile of rubbish argument again. So you're proud of these videos? You think you have debunked me or marginalized me or shown me to be the one at flaw and the corrupt individual and the individual not trying very hard and the individual bullshitting when you use that as an argument? Why would I pay somebody $2,000 if they can bring no audience to the conversation? Why would I pay them $2,000? Let's just say they're using a screen name, they're not even using their physicist name. Let's say I could actually find a physicist and he was hiding who he was. What value would it have? I could have a whole argument with him. He could use a fake voice like you. And what do I gain for the $2,000 I spent? I get nothing. I mean, that's just stupid. That you'd sit there and say you ridicule my rationality by saying somehow it'd be rational for me to pay somebody who's hiding their identity so I can't even humiliate them. I can't even cause them any public discomfort. And if I'm going to pay them $2,000 so they can say absolutely nothing as a response, I can say, well, where's your evidence that it takes 25 times the fuel to go 5 times as fast? And he just says, fuck you, I don't have any. What about the fact that Einstein actually said, it might be possible to use Jupiter to do a lensing experiment? Doesn't that say something? That's Einstein saying it before we had any space telescopes, before we could take advantage of the 400 times resolution from space. Clearly, after we had space telescopes, Jupiter's, well within the realm of a reasonable way to do the experiment. Has anybody tried it? No. I mean, you're so dishonest. You people are just so dishonest. Alright, so that's probably enough. Yeah, we'll call it a video. I mean, that's probably enough. If there's something else out there, I'll get to it later. Next time. And such. So forth and whatnot. So I wish you could come to the table with a real argument. You know, I wish you could really dissect something. You know, do a force diagram. Show us how it really works. Show us how it makes sense. You know, show us how when you're converting energy from a light thing to a heavy thing, or from a heavy thing to a light thing, that it is somehow possible to conserve kinetic energy and momentum. I don't think so.